All right, today we have a really incredible story for you. It's a story that sits right at the intersection of love, desperation, and some seriously cutting-edge technology. It's about one man, his best friend, and a pretty radical attempt to use AI to do what seemed impossible, to cure a death sentence. So let's get right into it. And that right there, that's really the emotional heart of this whole thing. That's Paul Conyngham talking about his rescue dog, Rosie. I mean, can you imagine? Faced with losing your best friend, you do anything, right? Well, he couldn't just stand by. He knew he had to do something. And what he did next, well, that's what makes the story so wild. Okay, so let's back up a little and set the scene here. Because before we get to all the high-tech wizardry, it all started with some really devastating news. Yeah, this is pretty much the moment every single pet owner just dreads. The vets gave their verdict, the cancer was aggressive, and they said she only had months to live. So for Rosie, and of course for Paul, the outlook was just grim. It was basically a death sentence. But here's where things take a turn. Instead of just accepting that fate, Paul decided to take this, honestly, an extraordinary gamble. He wasn't going to rely on medical training because he didn't have any. He was going to rely on what he knew best, technology. And you really have to appreciate the scale of this challenge. I mean, look at this. On one side, you've got Paul Conyngham. He's a tech entrepreneur from Sydney. But here's the kicker. He has absolutely zero biology training. And on the other side, one of the toughest, most complex problems in all of modern medicine, designing a custom cancer vaccine. The mismatch here, it's just wild. It's almost unbelievable. So you're probably asking, how on earth did he even start? Well, he put together what you could call a digital toolkit. First, he got Rosie's tumor DNA sequenced. This is key. It turns a physical thing, a tissue sample, into digital data. Then, and this is the amazing part, he used AI tools that are out there for anyone to use. He used ChatGPT to help him make sense of the genetic mutations and AlphaFold to model the proteins. You could almost think of these as his digital superpowers. Okay, so he's got the data, he's got the AI insights, but now comes the most critical step of all. How do you turn all of that digital information into an actual physical treatment that you can give to Rosie? And this is basically the pipeline he came up with. Step one, he sequenced the tumor's DNA, which cost about $3,000. Right away, that changes the game. It's not a biology problem anymore, it's a data problem. Then he let the AI loose on that data to find the exact mutations that were causing Rosie's cancer. And here's the genius part. He used that information to design a blueprint for a custom mRNA vaccine. The whole idea was to teach Rosie's own body, her own immune system, how to find and attack the cancer cells. Now, to be clear, Paul didn't do this all in his garage. He collaborated with actual labs at the University of New South Wales. And this quote from Professor Paul Torres, it's so telling. Because even the experts, the people who work with this kind of technology every single day, they were skeptical. They just didn't think they could pull it off quickly enough to actually help Rosie in time. Well, it turns out that skepticism was, well, wrong. Check this out. From the moment Paul locked in the vaccine's design using AI, it took the university labs less than 2 months to create the physical vaccine and get it delivered. I mean, that is just an incredibly fast turnaround for a completely custom-made medical treatment. Astonishing, really. So, they did it. They won the race against time. The vaccine was made, it was given to Rosie, but the biggest question of all was still hanging in the air. Was any of this actually going to work? And the answer? A huge, resounding yes. Get this, within just 1 month of getting the vaccine, Rosie's tumors had shrunk by 50%. By half. We're not talking about a tiny little improvement here. This was a massive, dramatic, and totally measurable success. But you know, numbers only tell you so much. This quote from Paul, this is what really paints the picture. Think about it. Rosie went from basically shutting down, being sad and lethargic, to having so much energy and life back that she was literally jumping over fences to chase rabbits again. That's the real success story, right? A return to health, a return to just being a happy dog. So this story is amazing, but it's also so much bigger than just one dog. What we're looking at here is a potential proof of concept for a whole new era in medicine. So the question becomes, what could Rosie's miracle mean for all of us? And it's really important to get this. This isn't happening in some isolated vacuum. This same kind of custom mRNA technology is already being tested in humans. You've probably heard about it. Moderna just ran a trial for melanoma patients that showed a 75% immune response rate. So what Rosie's story really is this incredible, real-world, super fast demonstration of the exact same ideas that are being tested in these huge, formal pharmaceutical trials. So yeah, the promise here is just enormous. And it's not just about doing things faster, it's about who gets to do them. This is what we mean when we talk about AI democratizing technology. It means that brilliant, super determined people who are outside the big research labs, people exactly like Paul, can now actually help solve some of our biggest problems. It totally shatters the old way of doing things. It means R&D could go from taking years down to just months. And it means these breakthroughs don't have to happen in just a few big labs around the world. The potential here goes way beyond cancer, too. Think about neurological diseases, rare genetic conditions, you name it. Okay, but let's be realistic for a second. The promise is huge for sure, but there are some major, major hurdles to clear before something like this becomes a mainstream treatment for people. The timeline for Rosie was crazy fast, but for human trials, you're looking at years of regulatory red tape. And the cost? Yeah, the design cost is lower, but the price tag for current human trials can be millions of dollars per patient. And even if you can design it, actually making these vaccines on a large scale is still a huge bottleneck. So that's where we'll leave it. What this incredible journey really shows us is that one dedicated person, armed with these powerful new AI tools, can do something that would have seemed like pure science fiction just a few years ago. It gives us this amazing glimpse into the future of medicine. Really, the question isn't if AI is going to revolutionize healthcare anymore. The real question is, how fast is it going to happen, and who's going to be the next one to be saved by it?